Our universe holds a galaxy that rewrites the rules of reality. Spinning in the distant cosmos, NGC 262 is not just another spiral of stars. It is a cosmic cabinet of curiosities, filled with phenomena so strange they defy our current laws of physics. By the end of this journey, you will have explored 25 of its deepest mysteries, each one a puzzle that could unlock new chapters in science or even reveal signs of intelligence beyond our own. We will encounter a black hole that sings in gravitational harmonies and stars that vanish without a trace. We will question if ancient light can freeze in time and if an entire nebula might be alive. So, what do you believe is waiting for us in the deepest parts of space? Our first stop is a signal from the void. Deep within NGC 262, astronomers detected the unmistakable heartbeat of a pulsar. These are the dense, rapidly spinning cores of dead stars, cosmic lighthouses that sweep beams of radiation across the cosmos with metronomic precision. This one's rhythm was flawless, a steady pulse of radio waves arriving like clockwork from a specific point in the galaxy. But when they pointed every other instrument at that exact same spot, they found nothing. No X-ray glow, no infrared heat, not even a faint shimmer of visible light. The patch of space was utterly, completely empty. They called it the phantom pulsar, a ghost beacon broadcasting from a place where nothing seems to exist. This creates a profound puzzle. Our models tell us a pulsar is a physical object, a city-sized neutron star with a powerful magnetic field. That field should generate emissions across the spectrum, not just in radio waves. So what are we listening to? Is it a neutron star shrouded in a material so exotic it absorbs all other light, a kind of cosmic stealth cloak? Or could the signal be something else entirely, a natural echo or a ripple in space-time itself mimicking a pulsar's beat? This phantom challenges the very link between a signal and its source, reminding us that in NGC 262, even the most familiar cosmic objects can become profound mysteries. This ghostly signal is not the only place where NGC 262 seems to ignore the rulebook. Far from the empty pulse, a different kind of defiance unfolds across a staggering volume of space. Picture a nebula so vast it could swallow entire solar systems, a faint and wispy cloud of gas and dust. Observers named it the Quantum Ripple Nebula for a reason that still baffles them. Within this cloud, something impossible happens. When a single particle in one region is excited by a stray photon, changing its energy state, that change is instantly mirrored by a corresponding particle in a completely different part of the nebula. These events are separated by light years, distances so immense that even light would take years to travel between them, yet the correlation is instantaneous and perfect. It is as if the entire nebula is a single, connected entity. In our laboratories on Earth, we can create a tiny hint of this behavior. It is called quantum entanglement, where two particles become linked so that measuring one instantly determines the state of the other, no matter the distance. Physicists call it spooky action at a distance, but that spookiness is fragile, confined to the subatomic world. It famously breaks down when scaled up to larger objects. For an entire nebula, a cloud of gas light years across, to exhibit this behavior is not just surprising. It is like finding that every grain of sand on every beach on Earth is somehow magically synchronized. The laws of physics as we know them say this cannot happen at such a macroscopic, cosmic scale. So what are we seeing? One radical theory suggests the nebula is not a normal cloud of gas at all, but a natural, galaxy-sized Bose-Einstein condensate. This is a state of matter where particles cooled to near absolute zero all collapse into the same quantum state, essentially behaving as one giant superparticle. Could some unknown process in NGC 262 have chilled this nebula to such an extreme, allowing it to act as a single quantum object on a stellar scale? Another, even more mind-bending idea points to the geometry of reality itself. Perhaps what we perceive as a vast, three-dimensional nebula is actually a shadow. A projection from a higher dimension where all points in the nebula are actually touching or intimately connected. From our limited perspective, they look separate, but in a higher dimensional reality, a change in one place is simply a change everywhere. The Quantum Ripple Nebula presents a cosmic-scale demonstration of a quantum mystery, forcing us to ask if the rules of the very small can govern the very large, or if we are glimpsing the true, interconnected fabric of the universe in a way no laboratory ever could. If the Quantum Ripple Nebula challenges our understanding of space, another region in NGC 262 shatters our concept of time. Astronomers refer to it as the chrono-distortion anomaly. Imagine sending two identical, perfect probes into this region, each carrying an ultra-precise atomic clock. You guide them on parallel paths, mere astronomical units apart. According to Einstein's theory of relativity, time for both probes should slow down at nearly the same rate due to the galaxy's gravitational field, but that is not what happens. One probe's clock ticks at a normal, expected pace. The other, right beside it, suddenly races ahead, as if hours are passing for it while only minutes pass for its twin. Then, a short distance later, the situation flips. The first probe's clock speeds up while the second one slows to a crawl. The result is a bizarre patchwork of time, a cosmic quilt where the fabric of reality is stitched together with threads that run at different speeds. This is not the smooth, predictable time dilation we expect from massive objects like black holes. This is a jagged, inconsistent distortion that appears to violate a cornerstone of physics known as general covariance. This principle essentially states that the laws of physics should be the same for all observers everywhere. A patchwork time zone where the rules change from one pocket to the next defies that fundamental idea. So what could possibly cause such a fractured timeline? One terrifying possibility is the existence of naked singularities. A singularity is the infinitely dense point at the heart of a black hole, normally hidden from view by the event horizon. A naked singularity, however, would be one without this cosmic curtain. It would be exposed, its infinite gravity warping spacetime in unpredictable and violent ways right out in the open. Could a swarm of these theoretical monsters, too small to form full black holes, be lurking in that region, each twisting time in its own chaotic way? Another theory points to exotic matter. This is not the normal atoms and particles we are made of. Exotic matter possesses strange properties like negative energy density or negative mass. If such matter clumps in uneven pockets, it could theoretically warp spacetime in opposing directions, creating these adjacent zones of fast and slow time. Picture it as a sea of invisible bubbles, some pushing time forward, others holding it back. The chrono-distortion anomaly presents a profound question. Is time itself not a smooth, universal river, but something more granular and variable? A substance that can have different textures and flows right next to each other. For any future traveler, this region would be a labyrinth of temporal confusion, where the simple act of moving from point A to point B could age you years relative to your companions. The fractured time of the chrono-distortion anomaly is a warning that in NGC 262, even the most violent endings can be stolen away. This brings us to a star that died without a sound. Astronomers had been watching a massive, aging giant for years, cataloging its final, frantic days. It began to pulse with an unstable rhythm, brightening dramatically as it burned through the last of its nuclear fuel. Then, their neutrino detectors registered the telltale spike. This was the crucial signal. Neutrinos are ghostly particles that stream out from a star's core in the moments before it collapses, a cosmic announcement that the final act has begun. All the models pointed to one inevitable, spectacular result: a supernova, a blast of light so brilliant it would outshine its entire host galaxy for weeks. Every telescope in range was trained on that point of light, waiting for the fireworks. They never came. Instead, the star simply winked out. One moment it was there, a brilliant beacon. The next, the patch of sky was empty. No expanding shockwave, no brilliant flash, no remnant nebula. It was a silent supernova. The star had undergone all the prelude for a grand cosmic explosion, only to vanish into utter darkness. The before and after images are haunting. The first shows a brilliant, unmistakable point of light. The second, taken just days later, shows nothing but black space, as if someone had simply erased it. So what happened? The leading theory is as terrifying as it is elegant. The star, in its final moments, may have collapsed directly into a black hole. Instead of its outer layers rebounding off the dense core in a titanic explosion, the entire structure simply fell inward past the point of no return. It was a total gravitational surrender. The core became so dense that not even light could escape, swallowing the star's entire identity in an instant. This failed supernova, if confirmed, is a rare and critical piece of the stellar life cycle puzzle. It suggests that for the most massive stars, a whimper is far more common than a bang. Our models of stellar evolution are built on the brilliant explosions we can see. This silent disappearance forces us to ask a sobering question. How many stars have died this way, vanishing from the cosmic record without a trace, leaving behind only an invisible black hole as their tombstone? The silent supernova reminds us that in this strange galaxy, even death can be a quiet, secretive affair. The silent death of stars stands in stark contrast to the center of NGC 262, where a different kind of cosmic giant refuses to be quiet. At the galaxy's heart lies a supermassive black hole, but it communicates in a way that defies all expectation. Instead of the chaotic, crashing crescendo of two black holes colliding, this one broadcasts a steady, complex harmony. Its gravitational waves, the ripples in space-time itself, pulse in a precise, repeating pattern. It is not a crash, but a song. Scientists listening to the data have described it as a cosmic symphony, with distinct low-frequency notes and higher harmonic overtones weaving together in a loop that lasts for months before repeating. This is the harmonic black hole, a singularity that sings. How can a region of infinite density, a place where physics breaks down, produce something so ordered and beautiful? The secret likely lies not in the black hole itself, but in the magnificent doomed orchestra that surrounds it. Picture the accretion disk, that swirling maelstrom of superheated gas and dust spiraling toward the event horizon. In most black holes, this disk is turbulent and chaotic, like a violent storm. But here, the disk appears to be structured with an almost impossible stability. Vast, dense rings of matter orbit in perfect, resonant harmony with one another. Think of it like a gigantic, cosmic pipe organ. Each ring of the disk is like a pipe of a specific length, vibrating at a specific frequency as it is stretched and compressed by the black hole's immense gravity. When these frequencies align in just the right way, they don't cancel each other out. They amplify, creating a coherent gravitational signature that echoes across the universe. When researchers translate these gravitational wave frequencies into sound waves our ears can hear, the result is eerie and profound. It is not a melody in any human sense, but a deep, resonant chord that shifts and evolves, a low hum punctuated by clearer, ringing tones. It is the sound of space-time itself being plucked like a string by the most powerful instrument imaginable. This harmonic signal forces a radical question. Could this be a natural, stable state for a supermassive black hole? One we have simply never detected before because our instruments weren't sensitive enough. Or are we witnessing something more deliberate? The precision of the harmonics is so exact that some theorists quietly speculate about an engineering principle. Could a sufficiently advanced civilization theoretically manipulate matter on a stellar scale to create such a resonant structure, perhaps as a beacon or even as a way to safely harvest immense energy? Whether natural or not, the harmonic black hole transforms our view of these cosmic monsters from silent voids into potential composers, writing their music in the fabric of reality. But the music of the black hole is a symphony of pure gravity, a distortion of spacetime itself. Elsewhere in NGC 262, a different kind of beauty reflects light in a way that seems almost crafted. Orbiting a young, brilliant star is a debris belt unlike any other. We expect these rings around infant stars to be chaotic mixtures of dust, rock, and ice, the raw materials for future planets. This one, however, is a river of light. The crystal planetesimal belt is composed of countless shards, some as large as mountains, tumbling in a slow, glittering dance around their sun. And each one is a single, geometrically perfect crystal. Spectroscopic analysis reveals they are not made of common ice or quartz. Their structure is something entirely new, a lattice of molecules arranged with flawless, repeating symmetry on a scale that defies natural geology. Sunlight does not simply bounce off these facets. It splits, dances, and refracts, turning the entire belt into a brilliant, shimmering halo of prismatic color. The sheer scale of the crystals is the first great puzzle. On Earth, large, flawless crystals form deep underground over millions of years in conditions of perfect stillness, constant temperature, and slow chemical deposition. A cosmic debris belt is the opposite environment. It is a violent, chaotic construction zone, full of collisions and wild temperature swings. For a crystal to grow to the size of a city block in such a place is like trying to grow a perfect ice sculpture in the middle of a hurricane. So how did this ring of jewels form? One natural theory points to a stellar tantrum. Perhaps the young star experienced a series of monstrous, superheated flares unlike anything in our records. These flares could have bathed the entire protoplanetary disk in a sustained, uniform blast of energy, essentially flash forging the swirling dust into a sea of glassy slag. Then, as the disk cooled with impossible rapidity and uniformity, this material might have crystallized all at once, like a cosmic windowpane freezing into a single sheet of ice. Another, more exotic idea suggests the primordial cloud that birthed this star was seeded with an unusual chemistry, rich in elements and compounds that naturally want to bond into large, stable crystalline structures even in the chaos of space. But the perfection of the geometry gives some researchers pause. Natural crystals, even large ones, contain flaws, inclusions, and irregularities. Preliminary data suggests these space-borne crystals have a purity and structural regularity that rivals our most advanced laboratory-grown semiconductors. This raises a provocative, quieter question. Could this be a sign of fabrication? For a civilization mastering its star system, a ring of giant, transparent crystals would be more than art. It could be a colossal energy collection array, focusing and channeling stellar radiation with perfect efficiency. Or it might be a form of cosmic computation, with each crystal facet acting as a data storage unit in a vast, slow-thinking machine, using light itself as its language. Whether a freak of cosmic chemistry or something more, the crystal planetesimal belt transforms a construction site into a gallery, proving that in this galaxy, even the building blocks of worlds can be objects of breathtaking and mysterious beauty. The crystalline perfection of a debris belt speaks to a universe capable of stunning order, but at the galactic core, a fountain erupts with the power to unravel reality itself. From the same region that broadcasts the harmonic black hole song, a colossal jet screams into the void. Seen in the fury of gamma-ray light, it is a torrent of energy stretching for thousands of light years. But its true nature is not just energetic, it is antithetical. Spectroscopic analysis reveals this jet is not composed of normal matter, not the protons and electrons that make up our world. It is a stream of almost pure antimatter, a flood of antiprotons and positrons blasting into the cosmos. This is the antimatter fountain, and its very existence is a cosmic paradox of containment. In our laboratories, containing even microscopic amounts of antimatter is a monumental challenge. It must be held in magnetic bottles suspended in perfect vacuum, because if it touches any normal matter, the two annihilate each other in a flash of pure energy. Yet here, an entire jet, light years across, is composed of this volatile substance. How does it not instantly destroy itself? The secret seems to lie in the jet's own magnetic architecture. Observations suggest the antimatter stream is sheathed in a cocoon of immensely powerful, spiraling magnetic fields. These fields act like the walls of a perfect cosmic pipeline, keeping the antimatter concentrated and away from the normal matter that drifts through interstellar space. Only at the very edges of the jet, where this magnetic sheath weakens, do we see the telltale flashes of gamma radiation, the brilliant sparks of matter and antimatter meeting in mutual annihilation. This creates a shimmering, deadly halo around the jet's length, the energy source required to manufacture and launch such a quantity of antimatter is almost beyond comprehension. It points to processes near the supermassive black hole that are far more efficient than anything we understand. Some theorists believe the intense gravitational and magnetic forces are tearing apart the fabric of spacetime itself, pulling virtual particle pairs, matter and antimatter that spontaneously blink into and out of existence apart before they can recombine and vanish. The black hole's power then corrals the antimatter particles and accelerates them into the jet. In this way, the antimatter fountain may be the universe's most powerful natural particle accelerator, far surpassing anything we could build on Earth. It is a cosmic laboratory performing experiments at energy levels we can only dream of, potentially creating exotic particles and conditions that reveal the fundamental laws of physics. For future science, a stable source of abundant antimatter is the holy grail of energy production and propulsion. This fountain, if it could ever be harnessed, represents power on a galactic scale. It forces us to wonder if such a natural wonder could ever become a resource, or if it remains a permanent, beautiful warning sign on the door to a realm where the building blocks of creation and destruction flow together in a single, impossible river. While the antimatter fountain showcases nature's raw power, another discovery in NGC 262 hints at a power of a different kind. A cluster of stars numbering in the dozens all share a strange and specific signature. Their visible light, the brilliant glow we see, is noticeably dimmer than it should be. Yet in the infrared spectrum, the range of light we feel as heat, they shine far too brightly. It is as if something is capturing the star's primary light, using its energy, and then releasing the leftover waste heat back into space. This pattern matches a theoretical concept proposed decades ago by physicist Freeman Dyson. A Type II civilization, one that has mastered its entire star system, might build a vast array of orbiting structures to capture a star's energy. This hypothetical construct is known as a Dyson swarm, and in this distant cluster we may be looking at not one but many candidates. An artist's concept reveals a breathtaking vision, not a solid shell but a dense, intricate cloud of countless individual collectors, solar panels the size of continents and habitats, all orbiting their sun in a complex dance, casting a web of shadows and glowing with the warmth of their industry. The scientific debate around this discovery is intense and beautifully rigorous. The leading natural explanation points to thick, circumstellar dust clouds. Young stars are often shrouded in the leftover material from their birth, and dust is excellent at absorbing visible light and re-radiating it as infrared heat. The astronomers searching for extraterrestrial intelligence must first rule out every possible natural cause, and dust is a very good one, yet the data presents stubborn quirks. The infrared signature is almost too perfect, too consistent across stars of different ages and types. The dust, if it is dust, would need to be distributed in a strangely uniform shell, not in the clumpy, chaotic disks we usually observe. This is where the Fermi paradox whispers its famous question. If the universe is so vast and old, where is everybody? The Dyson swarm candidates offer a potential spine-tingling answer. Perhaps they are right here in this data. A civilization reaching Type 2 status would need unimaginable amounts of power, and enclosing a star is the logical way to get it. Finding one would be the single greatest discovery in human history, proof that we are not alone and that intelligence can survive its technological adolescence. But the caution of science is its greatest strength. The truth may be more ordinary, a new and peculiar type of dust cloud we have never seen before. Or it may be extraordinary, the first faint thermal glow of a galaxy slowly being engineered by minds we cannot yet comprehend. The data does not yet say, and that tension between the thrilling possibility and the disciplined search for a simpler truth is where the real mystery lies. The search for cosmic engineers forces us to look at the invisible scaffolding of the universe itself. Deep within NGC 262, light from ancient galaxies does not travel in straight lines. It is bent, twisted, and shattered into fragments by an immense, unseen presence. Astronomers call this region the gravity lens maze. Gravitational lensing is a known effect, a prediction of Einstein's relativity where a massive object's gravity warps the fabric of spacetime, bending the path of light from objects behind it like a cosmic magnifying glass. Normally, this creates beautiful but singular arcs or rings, or perhaps multiple images of a single distant quasar. Here, however, the effect is magnified into a state of pure chaos. The foreground is not dominated by a single massive galaxy cluster, but by a dense, tangled web of dark matter. This mysterious substance, which does not emit or reflect light, reveals itself only through its immense gravitational pull. In this maze, the dark matter is clumped in dozens of dense knots, each acting as its own gravitational lens. The result is a visual cacophony. Light from a single background galaxy is not just bent once. It is captured by one dark matter clump, stretched into an arc. Then that arc of light passes near another clump and is bent again, and then again. Processed images reveal a kaleidoscope of recursive patterns, where faint, bluish smears of distant starlight are repeated, mirrored, and folded back upon themselves in a hall of mirrors written in gravity. It is as if you are looking at a galaxy through a room full of shattered, warped glass, each piece offering a different, distorted view. This maze is a goldmine for cosmologists. By meticulously tracing the paths of these twisted light beams, they can perform a kind of cosmic tomography, mapping the precise distribution and mass of the invisible dark matter that causes the distortion. It is the most detailed, three-dimensional map of dark matter ever conceived, but the map itself revealed a second, deeper mystery. The dark matter is not distributed in the expected, amorphous blobs or a smooth, random web. The reconstructed map shows a startling geometry. The dense knots appear to be arranged with a strange regularity, almost forming the vertices of vast, interlocking tetrahedrons or dodecahedrons, like a three-dimensional honeycomb etched into space on a scale of light years. This is profoundly unexpected. Dark matter, under the sole influence of gravity, should clump in a more organic, fractal, and chaotic way. A geometric distribution suggests an underlying order, a pattern that hints at something beyond simple gravitational collapse. Could this be a fossil imprint from the very birth of the universe, a relic of quantum fluctuations in the primordial soup that were frozen into the fabric of spacetime with geometric precision? Or does it point to a property of dark matter itself that we do not understand, perhaps a kind of repulsive force or interaction between dark matter particles that causes them to naturally arrange into stable, geometric lattices as they cool? The gravity lens maze does more than just reveal the invisible. It reveals that the invisible universe may be structured with a mathematical elegance we are only beginning to perceive, a hidden architecture waiting to be decoded in the twisted light of ancient galaxies. That hidden architecture of dark matter forms the backdrop for a discovery that touches on the very essence of life. Drifting through one of the galaxy's spiral arms is a vast, cold molecular cloud, a nursery for future stars. But when astronomers analyzed its light, they found a signature that made them double-check their instruments. The cloud, designated G234, is not just rich in simple molecules like hydrogen or carbon monoxide. Its spectrum lights up with the unmistakable fingerprints of complex organic chemistry. We are talking about amino acids, the building blocks of proteins. We are talking about simple sugars, the backbones of DNA and RNA, and we are not talking about trace amounts. The concentrations detected are hundreds, even thousands of times greater than those found in any similar cloud within our own Milky Way. This is the biosignature cloud, and it presents a fundamental question. Is this a supremely efficient natural laboratory, or is it a cosmic graveyard? The natural explanation is compelling. Molecular clouds are known to be chemical factories. On the frigid surfaces of dust grains, simple atoms meet and link, forming more complex molecules over millions of years. Cosmic rays and starlight provide the energy to drive these reactions. In G234, a perfect storm of conditions may have arisen. Perhaps it is exceptionally rich in key elements like carbon, oxygen, and nitrogen. Maybe its internal turbulence is just right, gently shaking the dust grains to help newly formed molecules break free without destroying them. It could be a chemical cascade that ran wild, producing a broth of prebiotic ingredients at an unprecedented scale. In this view, the cloud is a testament to the universe's innate creativity, a place where the steps toward life are written large across light years. But the staggering abundance of these molecules gives other researchers pause. On Earth, such a dense concentration of amino acids and sugars is not a sign of a sterile chemical process. It is a hallmark of biology. Life takes simple molecules and assembles them into complex structures with breathtaking efficiency. So, a quieter, more profound hypothesis emerges. Could this cloud be the aftermath of a cosmic-scale biological event? Imagine a civilization or even a diffuse, galaxy-wide ecosystem of life that flourished for eons. Then, some catastrophe occurs, a nearby supernova, the eruption of the galactic core. The event is not violent enough to vaporize everything, but powerful enough to sterilize worlds and scatter their organic remains into the void. The shredded remnants of countless biospheres, the dust of forests and oceans and perhaps even beings, could have been blown into space, eventually coalescing into this vast organic haze. The cloud would not contain living cells, but it would be saturated with the molecular fossils of life that once was. It would be a galactic compost heap, the recycled building blocks of a forgotten genesis. The spectroscopic data charts tell a silent, ambiguous story. Sharp, clear lines spike at wavelengths corresponding to glycine, alanine, and ribose. The signal is undeniable. But the chart cannot tell us if these molecules were assembled in the quiet cold of space or in the warm oceans of a lost world. This cloud forces us to confront a new dimension of the search for life. We have always looked for signals, for techno-signatures like radio waves or Dyson swarms. But what if the most common artifact of intelligence is not a beacon, but debris? What if a civilization's ultimate fingerprint is not a deliberate message, but the accidental, widespread pollution of its basic organic chemistry upon its galactic neighborhood? The biosignature cloud hangs in space, a tantalizing and somber possibility. It could be a cradle, proving the universe is pregnant with life's ingredients. Or it could be a tomb, suggesting that in NGC 262, life may have already risen, flourished, and returned to dust on a scale we can barely comprehend. The organic haze of the biosignature cloud speaks to the chemistry of creation, but in a different sector of NGC 262, physics itself seems to fracture under a different kind of pressure. Here, space is not filled with molecules, but with a seething, ionized storm. This is a region of superheated plasma, charged particles swirling in a chaotic dance. Yet their movement is not random. They spiral in precise, screaming arcs, converging on or fleeing from specific, isolated points in the void. These are not the familiar magnetic fields that always come in pairs, a north and a south forever linked. What we are witnessing is the impossible made real, a storm of magnetic monopoles. For centuries, since the days of James Clerk Maxwell, our equations for electricity and magnetism have been beautifully symmetrical, with one glaring exception. We find electric charges as isolated positives or negatives, but we have never found a magnetic charge alone. Every magnet, from a child's toy to the Earth itself, is a dipole. Cut a bar magnet in half and you do not get a separate north and a south. You get two smaller magnets, each with its own north and south pole. The monopole, a solitary north or south magnetic charge, has been a ghost in the equations of physics, a missing piece that would perfect the symmetry of the universe. In NGC 262, that ghost appears to have taken form. The animated magnetic field lines radiating from these points are not the looping arcs we know. They are like the rays of a star or the spines of a sea urchin, emanating outward in all directions from a single, central source. If you were to place a compass near one of these points, its needle would not align along a field line between two poles. It would point directly toward the center or directly away with an irresistible pull. This is the heart of the storm. The surrounding plasma acts as a brilliant tracer, illuminating these impossible fields. Positively charged particles stream relentlessly toward a negative magnetic monopole, while electrons whip in tight orbits around a positive one, creating brilliant miniature accretion disks of pure light and energy. The existence of magnetic monopoles is not just a curiosity. For theoretical physicists, they are potential proof of grand unified theories, the holy grail of modern physics. These theories attempt to describe the electromagnetic force, the weak nuclear force, and the strong nuclear force as different manifestations of a single, primordial force that existed in the extreme heat of the Big Bang. In those first moments, the theory predicts, conditions were so energetic that magnetic monopoles would have been created in abundance. Finding one now would be like discovering a fossil from the universe's first trillionth of a second, direct evidence of a time when all forces were one. The bizarre effects extend beyond mere proof. The monopole's pure unipolar fields would shred normal matter in ways a dipole field never could. A spacecraft passing through this storm would not just experience magnetic torque. Its very atomic structure could be polarized and stressed, with the nuclei of its atoms pulled in one direction and its electron clouds in another. It would be a region where the rules of chemistry and material science are rewritten by a fundamental force unleashed from its usual partnership. So what could create such a storm? One possibility is that we are witnessing the decay of a cosmic string, a hypothetical filament-like defect in space-time left over from the early universe. As such a string vibrates and snaps, it could theoretically release bursts of energy that condense into these primal magnetic charges. Another, more unsettling idea is that this region is a window. The storm may not be a local phenomenon at all, but a place where the geometry of our universe briefly touches another dimension or a different cosmological domain where monopoles are common, their fields bleeding through like light under a door. The magnetic monopole storm presents a profound duality. It is both a destructive maelstrom that would annihilate any known technology and a beacon of ultimate understanding, a place where the deepest symmetries of reality are laid bare. It asks us if the universe's most elegant truths are only visible in its most violent and unforgiving corners. While the magnetic storm reveals forces from the universe's first moments, another discovery in NGC 262 seems to capture the very sound of its birth. Across the entire galaxy, superimposed over the local light of its stars, astronomers have mapped a faint, all-sky whisper of microwave radiation. At first glance, it looks familiar, a near-perfect match for our own cosmic microwave background, the afterglow of the Big Bang that fills every corner of our observable universe. But the closer they looked, the more the data deviated. This is not our CMB, it is an echo from a different beginning. Side-by-side comparison maps tell the story. Our cosmic microwave background is a snapshot of the infant universe, 380,000 years after the Big Bang, showing tiny temperature fluctuations that are the seeds of all future galaxies. The map from NGC 262 shows a similar pattern of hot and cold spots, a cosmic fingerprint of primordial structure, but the fingerprints do not match. The patterns are rotated, the fluctuations are sized differently, and the overall temperature is subtly colder. It is as if you found two nearly identical snowflakes, each beautiful and complex, but upon inspection, their crystalline structures are fundamentally, undeniably unique. This anomaly has a staggering implication. The cosmic microwave background is supposed to be universal, the literal wall of fire from the single beginning of everything we can see. Finding a different one localized to a single galaxy suggests that NGC 262, or the space it occupies, may have a different origin story. One leading theory is that we are seeing evidence of a cyclic cosmology. In this model, the universe does not have one single beginning and one eventual end. Instead, it undergoes endless cycles of expansion, collapse, and rebirth. Each Big Bang is preceded by a big crunch. The faint microwave signal in NGC 262 could be the fading remnant, the last thermal echo from the universe that existed before our own. In this view, our entire cosmos is just the latest iteration in an infinite series, and this galaxy sits in a region where the ghost of the previous cycle never fully dissipated. An even more profound interpretation points to the multiverse. If our universe is one bubble in a vast, frothing cosmic foam of other bubble universes, each with its own Big Bang and its own physical laws, then collisions or close encounters between these bubbles might be possible. The anomalous microwave background in NGC 262 could be a bruise, a scar on the sky left from when this galaxy's region of space gently brushed against the fading afterglow of a neighboring universe's creation event. This is not light from stars, it is fossil radiation from a reality that is not our own, a message in a bottle that washed up on the shore of our cosmos. For cosmologists, this echo is a potential Rosetta Stone. By decoding its patterns, they could learn about the fundamental constants and initial conditions of a completely separate cosmic genesis. Was that other universe governed by the same laws of physics? Did it have more dimensions or fewer? Did time flow in the same direction? The silence of this microwave whisper holds answers to questions we have not yet learned how to ask. It transforms NGC 262 from a place within our universe into a possible window out of it, a place where the walls between realities are just thin enough to hear the distant echo of another creation. That cosmic echo from another beginning is a whisper of profound isolation, but within the same galaxy, a group of stars moves with a unity that defies the very idea of solitude. Drifting through one of the spiral arms is a cluster of 7 suns, each burning with its own fierce light. They are not particularly close together, separated by distances that would normally swallow entire solar systems. Yet, as they travel, they do not drift like individual ships on a sea. They move as one solid, unchanging shape. The cluster is quantum-locked. Measure the distance from the blue giant at the cluster's heart to the red dwarf at its edge, and it is always exactly 43.25 light-years. Not 43.24, not 43.26. The same impossible precision holds for every single pairwise distance between all 7 stars. They are like points on a perfect, invisible geometric frame hurtling through space, a constellation that refuses to distort. This is the rogue quantum cluster, and its behavior mocks the fundamental freedom of celestial motion. In our normal understanding of the cosmos, every star in a cluster is bound by their mutual gravity, like dancers holding hands as they spin, but gravity is a flexible bond. It allows for movement, for orbits, for subtle shifts as stars tug on each other. This cluster shows no such flexibility. Its internal geometry is frozen. Even more baffling, the cluster itself is moving as a whole through the galaxy, passing by other stars and gas clouds. Those external gravitational forces, which should pull differently on the nearer stars versus the farther ones, seem to have no effect. The entire structure simply translates through space, its internal distances remaining rigidly constant, as if it were a single, solid chandelier being carried across a room. Imagine tying 7 marbles together with pieces of string of fixed lengths and throwing the whole assembly. That is how this cluster behaves, but on a scale of light years, with stars as the marbles and with no detectable strings at all. The physics of this are not just unusual, they are prohibitive. For the stars to maintain such exact distances, the space between them would have to be utterly rigid, immune to the stretching and compressing effects of gravity and motion. One radical theory suggests we are not looking at stars moving through space, but at a defect in the fabric of reality itself. The cluster might be anchored to a knot in the space-time foam. This is a theoretical concept where, at the smallest possible scale, space-time is not smooth. It is a turbulent, bubbling sea of virtual particles and quantum fluctuations. Under incredible pressure or energy, this foam could theoretically stabilize into a macroscopic structure, a kind of crystalline lattice in the background of the universe. The stars in this cluster might not be holding their positions. They might each be pinned like butterflies in a display case to fixed points on this immovable quantum lattice. As the lattice drifts, they drift with it, perfectly preserved. Another, even more profound idea involves a unified field effect. The dream of physics is to describe all fundamental forces, gravity, electromagnetism, the nuclear forces, as different aspects of one single overarching force. In the extreme conditions near these stars, perhaps that unified field briefly reasserts its primordial nature. The stars could be bound not by gravity alone, but by a perfect, stable equilibrium of all forces combined, a cosmic glue that locks their space-time coordinates into an unbreakable relationship. This would be a natural phenomenon of unimaginable rarity, a place where the universe's underlying unity becomes visibly manifest in the arrangement of suns. The cluster would then be less a group of stars and more a single, complex expression of physics written across light years. It presents a silent, majestic question. Are we seeing a flaw in the cosmos or a glimpse of its truest, most perfect geometry? The frozen geometry of the rogue quantum cluster suggests a universe of hidden connections, but near the galaxy's central black hole, a different kind of connection is being severed and paradoxically recorded. There exists a boundary not of distance but of information. Just outside the event horizon, the point of no return, lies a region scientists call the information horizon. Here, the universe seems to perform a desperate cosmic backup. As matter and energy spiral toward oblivion, all the data about them, their composition, their structure, their quantum states, does not simply vanish into the singularity. Instead, it appears to be scrambled and imprinted onto the two-dimensional surface of the event horizon itself. Picture the black hole not as a dark pit, but as the universe's most extreme hard drive. Every atom, every photon, every star that falls in adds its unique information to a frenzied, microscopic script written on the sphere of darkness. This is not a metaphor. According to the holographic principle, all the information needed to describe a three-dimensional volume of space can be encoded on its two-dimensional boundary, like a hologram where a flat surface contains the data for a full three-dimensional image. In this case, the black hole's entire interior, a volume of space, is described by the quantum bits flickering on its spherical surface. The paradox this creates is profound. For decades, physics has been locked in a battle between two of its most successful theories. Quantum mechanics states that information can never be destroyed, it can only be scrambled or rearranged. General relativity, which describes black holes, says that anything crossing the event horizon is lost forever, its information erased from our universe. This is the black hole information paradox. The information horizon is where these two titanic ideas might find a truce. The data is not destroyed, but it is transformed into a form so alien, so entangled with the black hole's own quantum properties that it is effectively unreadable to any outside observer. It is like watching a library burn. The information in the books is not technically gone. It has been converted into heat, light, and smoke. But reassembling a single sentence from the ashes is, for all practical purposes, impossible. Yet, in NGC 262, we may be seeing a crack in that impossibility. The harmonic black hole's stable, resonant accretion disk seems to be influencing this process. Theorists suggest its orderly vibrations might be stirring the information imprint on the horizon in a subtle, periodic way. This could create faint, modulated ripples in the black hole's Hawking radiation, the theoretical thermal glow emitted from just outside the horizon. It would be akin to detecting a faint, rhythmic static in the noise of a detuned radio, a static that carries the ghostly signature of everything the black hole has consumed. If true, this means the event horizon is not a smooth, featureless membrane. A diagram reveals it as a seething, pixelated sphere of unimaginable temperature and density, each Planck-sized area flickering with encoded data. The patterns are not static, they churn and evolve as the black hole feeds, a living hologram of its own history. This leads to a staggering philosophical implication. If the information of everything that falls into a black hole remains preserved on its surface, then in a sense, nothing ever truly enters the black hole at all. The three-dimensional reality of the interior, with its crushing singularity, might be an illusion, a projection from the data written on the two-dimensional boundary. We are left to wonder if our own reality, the vast three-dimensional cosmos we inhabit, could itself be a holographic projection from information stored on some distant, two-dimensional surface at the edge of the universe. The information horizon forces us to consider that the deepest truths of existence might not be written in the language of matter and energy, but in the indelible script of information itself. The holographic nature of the information horizon suggests reality might be a projection, but in one dense nebula, the universe seems to be projecting nothing at all. This region, catalogued as Nursery GX7, has all the classic hallmarks of a stellar maternity ward. Vast clouds of molecular hydrogen are collapsing under their own weight, compressed by shock waves from nearby supernovae. Telescopes detect the telltale infrared glow of immense gravitational energy being released, the heat of birth. Yet, when astronomers point their most powerful optical and ultraviolet instruments at the heart of this activity, they find a profound emptiness. No brilliant blue-white infant stars, no flickering protostellar jets, no glittering open clusters. The nursery is full of the sounds of construction, but the builders and their creations are invisible. This is the dark star nursery, and it presents a radical hypothesis. What if the stars being born here are not made of the normal matter that shines? What if they are powered by something else entirely? The key lies in the maps. An infrared survey shows the region blazing with heat, a bright, chaotic smear against the cooler dust. Overlaid on this, a gravitational lensing map reveals the true architecture. The invisible dark matter in this region is not a diffuse haze. It is concentrated into incredibly dense, knotty filaments woven through the gas clouds like a skeleton. The correlation is too perfect to be coincidence. The hottest infrared spots align precisely with the densest knots of dark matter. This has led theorists to a breathtaking possibility. We may be witnessing the birth of the universe's first stars, not as we know them, but as they might have been at the very dawn of time. These would be dark stars. In this model, a dark star is not a black hole. It is a vast, puffy sphere of normal hydrogen and helium, but at its core, instead of the nuclear fusion that powers our sun, a different engine runs. It is fueled by the annihilation of dark matter particles. The theory goes that in the early universe, dark matter was much denser and hotter. As the first protostars began to form, they would have gathered immense halos of this dark matter around them. If certain types of dark matter particles are their own antiparticles, they would annihilate upon contact, releasing a torrent of energy as gamma rays, neutrinos, and ordinary particles. This annihilation energy could be enough to heat the gas of a forming star, preventing it from ever becoming dense and hot enough to ignite nuclear fusion. The star would stabilize, ballooning to a colossal size, perhaps millions of times the diameter of our sun, yet glowing with a relatively cool, deep red or infrared light from its surface, powered from within by the silent fireworks of dark matter destruction. In nursery GX7, the conditions may be a cosmic echo of that primordial era. The dark matter is so densely packed that as normal gas clouds collapse, they are immediately saturated with this exotic fuel. The annihilation process begins, heating the gas and halting the collapse before a traditional star can form. What we see as infrared glow is not the heat of gravitational contraction alone, but the waste heat from this dark matter engine. These objects would be nearly impossible to see directly. Their surfaces would be too cool to shine brightly in visible light, and their immense, diffuse structures would have a very faint profile. They would be ghosts in the nursery, warming their cribs with a fire we cannot see. If dark stars exist, they change everything about stellar evolution. They could be the missing precursors to the supermassive black holes at the centers of galaxies, growing to enormous sizes before their dark matter fuel runs out and they finally collapse. They represent a completely different path for cosmic structure, a shadow lineage of stars that lived and died by a different set of rules. This quiet nursery, then, might not be a place of absence, but a gallery of cosmic giants sleeping in the dark, powered by the most mysterious substance in the universe. While dark stars hint at a shadow lineage of cosmic giants, the fabric of space itself can bear scars from an even more ancient trauma. Stretching across a quiet sector of NGC 262 is a flaw in reality so profound it warps the light of everything behind it. This is the cosmic string vibration. Imagine space-time not as a smooth, stretchy sheet, but as a vast, frozen lake. When water freezes, imperfections can form cracks and fissures trapped in the ice. A cosmic string is theorized to be a similar defect, but one frozen into the fabric of the universe during its first moments of existence, a relic from when the fundamental forces of nature split apart. This one is not a myth. We detect it because it acts as the ultimate gravitational lens, but with a bizarre signature. Instead of creating arcs or rings of light, this string is a perfectly linear distortion. Galaxies directly behind it do not appear smeared. They appear duplicated, split into two identical mirror image copies lined up perfectly on either side of an invisible line. A graphic reveals the effect, a faint razor-straight seam across the star field with paired galaxies glowing like pearls on a string. It is a rip in the cosmos, a place where space itself is pinched. The true mystery, however, is not just its existence but its movement. This cosmic crack is not static, it vibrates. Like a violin string plucked at the birth of the universe, it oscillates at a specific, incredibly low frequency. These vibrations send subtle ripples through the surrounding gravitational field, causing the paired images of the background galaxies to shimmer and shift their separation by a minuscule amount over decades. Measuring this frequency is a direct line back to the universe's infancy. The theory is elegant. In the extreme heat just after the Big Bang, all forces were unified. As the cosmos expanded and cooled, it underwent a series of phase transitions like steam condensing into water. Each time a force broke free from the unified whole, when gravity split off, when the strong nuclear force separated the fabric of reality could have developed cracks and defects. A cosmic string is a fossil of that moment of symmetry breaking. The tension and mass of the string, and thus the frequency of its vibration, are determined by the energy scale of that specific transition. By measuring the string's hum, physicists could, in principle, read the energy signature of the universe when it was a fraction of a second old. It tells us not just that the universe cooled, but how it cooled, revealing the specific sequence and timing of its most fundamental transformations. The implications are staggering. This vibrating filament is a tuning fork left over from creation, and its note holds data no particle accelerator on Earth can ever reproduce. If we can precisely measure its oscillation, we could distinguish between competing theories of grand unification. Does the vibration match the predictions of a theory where all forces merge at one specific immense energy? Or does it point to a more complex stepped process? Furthermore, the string's interaction with the galaxy around it is a unique laboratory. As it vibrates, it theoretically emits low-frequency gravitational waves, a constant, whispering background hum beneath the louder crashes of black hole mergers. Detecting that hum would open an entirely new window into the cosmos, one sensitive to the most ancient structures imaginable. This single, faint line across the sky is more than a curiosity. It is a historical document written in the geometry of space-time, a vibrating record of the universe's first and most dramatic growing pains. That cosmic string's deep hum is a vibration from the universe's infancy, but in the present day, a different kind of precise cosmic clock is ticking down toward a profound mystery. Orbiting each other in a dizzying, relativistic dance are two pulsars, the dense, spinning cores of dead stars. This binary system is a gift to physicists, a natural laboratory of unimaginable precision. Each pulsar is a perfect celestial metronome, its radio pulses arriving at Earth with such regularity you could set your watch by them. By tracking the subtle variations in these pulses as the pulsars whirl around each other, scientists can measure their orbital decay with astonishing accuracy. According to Einstein's theory of general relativity, the immense gravity of these objects should cause them to lose orbital energy, spiraling inward by emitting gravitational waves. The equations predict exactly how fast that inward spiral should happen, and for decades the measurements matched the prediction perfectly, a triumphant confirmation of our understanding of gravity. But the latest data, represented in a stream of numbers beside an animation of their frantic orbit, now shows a tiny, persistent deviation. The pulsars are spiraling together just a fraction of a percent faster than they should be. This is the paradoxical pulsar pair, and that minuscule mismatch is sending shock waves through the foundations of physics. In a field built on decimal places, a discrepancy this small and this consistent is not an error. It is a signal. It suggests that something else is at work, stealing away orbital energy just a little more efficiently than gravity waves alone. One possibility is the shadow of a hidden dimension. Some theories that seek to unify gravity with quantum mechanics, like string theory, require extra spatial dimensions beyond the three we experience. These dimensions would be curled up or compactified at scales far smaller than an atom, but their presence could subtly alter how gravity propagates over the distances between these pulsars, allowing energy to leak into these unseen dimensions and accelerating the orbital decay we observe. Another explanation points to a new, very weak force in nature. We know of four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. Could there be a fifth, one that interacts only with extremely dense matter like neutron stars? This force would be too feeble to detect in Earth laboratories or in most celestial systems, but in the extreme gravity and rapid motion of this pulsar pair, its effect might finally become measurable. The crisis this creates is beautiful in its precision. General relativity has passed every test thrown at it for over a century, from the bending of starlight to the detection of gravitational waves. To see it potentially fail, even by such a tiny amount, in such a clean laboratory is like finding a single, misplaced stitch in a tapestry you believed was flawless. It tells us the tapestry is even more complex and wondrous than we thought. The paradoxical pulsar pair does not demolish Einstein's work. It points beyond it, whispering that our map of the cosmos, for all its detail, is still missing a few faintly drawn lines. The precision of pulsars gives us a measure of cosmic time, but in one nebula, time seems to abandon its forward march entirely. Drifting through a spiral arm is a cloud of such strange composition that light itself becomes trapped in a kind of eternal present. This is the nebula of frozen light. From a distance, it appears as a typical emission nebula, glowing with soft pinks and blues from energized hydrogen. But peer into its heart with instruments that can dissect time as well as light, and you witness a scene of impossible stillness. There, suspended within the shimmering plasma, are the perfect static images of ancient supernovae. These are not artistic renderings or afterglows. They are crisp, detailed snapshots of stellar explosions that occurred thousands of years ago, captured and held as if pressed between the pages of a cosmic book. The effect is breathtaking. A visual reveals these frozen scenes scattered like glowing murals across the nebula's vast interior. A brilliant, intricate shockwave frozen in mid-expansion, a ring of ejected material hanging perfectly still, a central remnant glowing without flicker. They are moments of unimaginable violence preserved in perfect, silent tranquility. The secret lies not in time stopping, but in light slowing to a crawl. In a vacuum, light travels at its universal speed limit, approximately 186,000 miles per second. But when light passes through a medium, it interacts with atoms, slowing down. In water, light travels about 25% slower. In a diamond, it slows to less than half its vacuum speed. The nebula of frozen light takes this principle to an interstellar extreme. Its clouds are not simple hydrogen. They are a supercooled exotic plasma saturated with certain elements like strontium and ytterbium under immense pressure. Under these specific, rare conditions, the cloud's refractive index, its ability to bend and slow light, becomes astronomically high. Photons from those ancient supernovae entered this nebula long ago and were almost instantly bogged down, their speed reduced to mere meters per second, a pace slower than a walking human. To light trying to escape this region, the nebula is a cosmic tar pit. This creates the illusion of frozen time, because the light from different parts of the supernova event is all traveling through the same slow medium. It all arrives at our telescopes at nearly the same time, even though the photons were emitted over days or weeks. Imagine a marathon where all the runners enter a zone of thick mud at the same point. Even though they started at different times, they all become bunched together, moving in unison at a snail's pace. From the finish line, it looks like a single, unmoving crowd. That is what we see. The nebula has captured a slice of time, a few weeks of a star's death throes, and stretched that slice across centuries of observation. We are not seeing a real-time event. We are seeing a light echo that has been smeared and suspended by physics. The extreme conditions required are a recipe found nowhere else. The nebula must be incredibly cold to reduce atomic motion, under precise pressure to maintain the plasma state, and chemically doped with just the right elements to interact with specific wavelengths of light. It is a natural optical computer of immense scale and accidental design. The implications are as profound as the view. If we could enter such a nebula, the universe outside would appear to blaze forward in a blinding rush, centuries passing in seconds. Within the cloud, you could theoretically watch a single beam of light drift lazily past, tracing its path with your eye. It raises a tantalizing, almost philosophical question. If information is carried by light, and light can be slowed to a standstill, can information itself be stored this way? Could these glittering, static scenes be more than a cosmic curiosity? Could they be a natural archive, a library where the universe accidentally records its own most cataclysmic moments in a medium of slow light, waiting for a future observer to learn how to step inside and read them? The frozen light of the nebula captures a single, violent moment, but elsewhere in the galaxy, motion itself is being orchestrated on a scale that mocks natural chaos. Astronomers mapping the precise velocities of millions of stars in one quadrant noticed something unsettling in the data. The stars were not moving randomly under the galaxy's gentle gravitational sway. Their motions traced out a vast geometric interference pattern, as if each star were a single pixel in a cosmic film strip, revealing a frame of something impossibly large. This is the galactic megastructure, and the pattern it paints is a perfect, rotating hexagon inscribed across hundreds of light years. Statistical analysis has all but eliminated a natural origin. The probability of this precise geometric alignment arising from chance gravitational interactions is less than 1 in several billion. It appears to be a deliberate signature, a fingerprint pressed into the fabric of the galaxy itself by something with power over suns. So what could possibly create such a pattern? The leading hypothesis is as awe-inspiring as it is terrifying. We may be looking at the early stages of a stellar engine, a theoretical megastructure of unimaginable ambition. The concept, proposed by scientists like Freeman Dyson and later refined by others, involves using a star's entire energy output not just for power but for propulsion. One design, known as a Shkadov thruster, would use a gigantic parabolic mirror larger than the star itself to reflect a portion of the star's light back on it. The radiation pressure from this reflected light would create a net thrust, slowly pushing the star and any planets or structures orbiting it through the galaxy. But the hexagon pattern suggests something far more complex and coordinated than a single thruster. It implies a network, a cage of forces acting in concert on dozens, perhaps hundreds of stars, aligning their movements to create this rotating geometric scaffold. The energy required to impose such order on stellar motions is beyond our comprehension. It would necessitate technologies that can generate and control gravitational or magnetic fields on a stellar scale, or perhaps manipulate space-time itself to create preferred pathways for stars to follow. The engineering principles involved are not just an extension of our own. They represent a leap over a chasm we have not yet even approached. To build on such a scale, a civilization would need to command the resources of entire solar systems, forging materials in the hearts of stars and assembling structures over millennia or eons. It would be architecture where the building blocks are suns and the blueprint is written in gravity. The sheer audacity of the project forces a profound question. What purpose could justify such an immense undertaking? One possibility is navigation. Moving a collection of stars in a coordinated pattern could be a way to steer a region of the galaxy, perhaps to avoid a future collision with another galaxy or a deadly gamma-ray burst. Another, more existential reason might be survival on a cosmic timeline. If a civilization sought to escape the eventual heat death of the universe, a stellar engine might be the first step in a billion-year journey toward a more hospitable region of the cosmos. Or the structure might not be an engine at all, but something even more strange, a kind of computational matrix, using the predictable motions of stars as a clockwork mechanism for calculations on a galactic scale, a computer built from gravity and time. The data does not yet show a completed structure, only its ghostly outline in the motions of stars. This suggests we might be witnessing a project under construction, a cosmic skyline half-finished, its ultimate shape and purpose still hidden from us. We are left staring at a statistical anomaly that whispers of minds and machines whose ambitions are written not in radio signals, but in the rearranged orbits of suns. The sheer scale of this hexagon challenges our very definition of what engineering can be. If it is a Kadov thruster network, its purpose is not to move a single star, but to steer an entire sector of the galaxy. Picture a fleet of colossal mirrors, each one larger than a solar system, positioned with exacting precision around hundreds of suns. Their combined radiation pressure would act like a gentle but irresistible hand on the cosmic tiller, nudging this entire celestial neighborhood onto a new course over millions of years. But why? The most plausible reason is survival. Perhaps this region of NGC 262 is on a collision path with another spiral arm, or a deadly wave of radiation from the galactic core is approaching, moving the stars and any civilizations that might live among them. Could be a trillion-year evacuation plan, a migration executed at a glacial pace to ensure continuity. The energy signatures support this staggering idea. Telescopes detect faint, coordinated pulses of infrared radiation from the vertices of the hexagon, the expected waste heat from unimaginably vast energy collection and projection systems. It is the thermal signature of industry on a scale that dwarfs planets. Yet another hypothesis suggests the structure is not for travel, but for thought. It could be a cosmic-scale computer, a gravity-based processor. In this model, the stars are not being pushed, they are being used as ultra-precise clocks and weights. Their meticulously orchestrated orbits and gravitational interactions could be performing calculations too complex for any silicon-based machine. Each star's position, velocity, and mass might represent a variable in an equation spanning light years, with the subtle tugs between them acting as logical operations. What kind of problem requires a computer built from suns, perhaps modeling the ultimate fate of the universe itself, or simulating the conditions of other dimensions? The hexagon's perfect, repeating geometry lends itself to this idea. It is the stable, resonant framework needed for reliable computation over eons. The faint energy signatures we detect might not be waste heat from thrusters, but the occasional power surge for a specific calculation, or the maintenance of the delicate gravitational lattice that holds the entire system in its precise configuration. Then there is the most haunting possibility. We might be looking at a monument or a tomb. The structure could be the artifact of a civilization that achieved godlike power only to vanish. In this scenario, the hexagon is not functional in any practical sense we understand. It is a signature, a final statement carved into the galaxy itself, meant to endure long after its builders are gone. It could be a memorial to their existence, a warning to others, or even a work of art on a canvas of stars. The energy signatures we see could be the faint, dying embers of systems on automatic maintenance, a ghostly caretaker program running on empty for millennia. This idea touches on a profound cosmic loneliness. If a civilization can rearrange stars, what could possibly cause its end? The structure's very existence suggests a mastery over matter and energy that should confer near immortality. Its persistence and the silence around it implies a fate so absolute it could erase even those who commanded suns. Construction methods for any of these purposes bend the mind. We are not talking about assembling steel girders in orbit. This is engineering with the fabric of reality. To move or manipulate stars, a civilization might need to harness the energy of black holes, create stable wormholes to transport materials, or synthesize matter from pure energy. They might use self-replicating machines, von Neumann probes, that convert entire asteroids and comets into more probes until a swarm of trillions can envelop a star. The hexagon's perfection suggests a construction process that is not just powerful but patient, operating on timescales that make human history feel like a single heartbeat. It forces us to reconsider our place in cosmic history. We look for radio signals and Dyson swarms, but a truly advanced intelligence might leave its mark not in ephemeral communications, but in the altered architecture of the galaxy itself. The silent, rotating hexagon in the star field may be the ultimate signature, one that asks if we are simply too early or too late to meet the architects. This silent hexagon of moving stars is a monument to cosmic patience, but elsewhere in the galaxy, patience has run out. A small, distinct constellation has been systematically erased from the sky. For over a century, astronomers charted a tight cluster of 7 moderately bright stars, a familiar asterism in the NGC 262 catalogue. Then, one by one, they began to fade. A time lapse of the region over 50 years tells a chilling story. The first star dims over a decade, its light softening until it merges with the black. 5 years later, its neighbor follows suit, then another and another in a slow, deliberate sequence until the patch of sky is empty, the constellation scrubbed from existence. These were not massive, unstable giants prone to supernova. They were stable, middle-aged stars similar to our own sun, with billions of years of fuel left. They did not explode, they were turned off. The immediate, natural suspicion is a colossal dust cloud drifting through the line of sight. Interstellar dust is excellent at blocking starlight. But the data refuses to cooperate. If a single dust cloud were responsible, all the stars would dim simultaneously and at roughly the same rate as the cloud passed in front of them. Instead, the dimmings were sequential and individual, each star fading on its own unique timetable. Furthermore, infrared telescopes detected no corresponding glow from warmed dust around any of the stars. The dust simply wasn't there. Another natural possibility is something intrinsic to the stars themselves. A previously unknown phase of stellar evolution where a star quietly contracts into a near-invisible black dwarf far ahead of schedule. Yet the stars showed no signs of the internal turmoil that would precede such a radical transformation. Their spectra remained calm and normal right up until the fade began, as if a switch had been flipped. This leads to the staggering, almost unspeakable hypothesis. Could this be an act of stellar-scale engineering? The concept is known as star lifting, a theoretical technology for a civilization that has truly mastered its sun. The idea is to gradually harvest a star's plasma, its raw hydrogen and helium, for raw materials or to control its output. By using immense magnetic fields or other means, a civilization could siphon off a star's mass, reducing its core pressure and slowing its fusion reactions. The star would dim in a controlled, gradual manner, exactly as observed. The harvested material could be used to construct unimaginable megastructures or to build a fleet of generation ships for a galactic exodus. The sequential nature of the dimming is what chills the spine. It suggests a project with a schedule, a blueprint being followed across multiple solar systems. One star is harvested to a certain level, then the vast machinery moves on to the next. It is resource management on a scale that treats suns as reservoirs to be drained. Consider the implications of such a capability. A civilization that can dim a star is not just harvesting energy, it is controlling the fundamental engine of its solar system. It could extend a star's lifespan by billions of years by carefully regulating its fuel burn, or it could deliberately end a star's life to reclaim its materials. The purpose behind the vanishing constellation could be pragmatic. Perhaps those stars were in the way of a larger project like the galactic hexagon and needed to be cleared. Or it could be something more existential. Perhaps the civilization that did this faced a threat so great it needed to gather every possible resource, even the very stars themselves, to survive. The time lapse of their disappearance is not just a record of an astronomical event. It is potentially a historical document of a decision made millennia ago, a decision to unmake suns. We are left staring at an empty patch of sky, forced to wonder if the greatest evidence of intelligence is not what is built, but what is carefully, methodically taken apart. The vanishing of stars leaves us contemplating the immense power to erase, but in a different sector of NGC 262, the universe reveals its most fundamental texture, not by hiding it, but by violently magnifying it. Here, the void between stars is not empty and smooth. It churns and froths. Space itself appears to boil. This is the quantum foam manifestation, a place where the chaotic, probabilistic nature of reality at the smallest scales erupts into plain view. Theoretically, at the unimaginably tiny Planck scale, space-time is not a continuous fabric. It is a seething, turbulent foam. Virtual particles and antiparticles constantly blink into and out of existence, borrowing energy from the vacuum before annihilating each other to repay the debt. This quantum foam is the foundation of everything, but it is supposed to be hidden, its effects averaging out to produce the smooth, predictable space we navigate. In this region, that averaging has catastrophically failed. Visualizing it is a challenge of cosmic proportions. An artist's rendering would show space not as a black sheet dotted with stars, but as a bubbling, effervescent broth. Each bubble or fluctuation in the foam might be light years across, shimmering with transient energy. Within these vast bubbles, you would witness the spontaneous creation and destruction of particle pairs on a macroscopic scale. Not just electrons and positrons, but protons, neutrons, and even stranger, short-lived entities flashing into being for an instant before vanishing back into the quantum static. It is a cosmic-scale display of the universe's underlying uncertainty, a place where the void is alive with creation and destruction. For this to happen, the energy density in this region must be staggering. In our normal vacuum, the energy fluctuations are incredibly weak and fleeting. To inflate these quantum events to a visible scale requires injecting an immense amount of energy directly into the fabric of space-time itself. One possible source is the violent decay of a false vacuum. Imagine the universe's fundamental fields are like balls resting in a valley, a state of true, stable vacuum. A false vacuum is a shallower dip in that landscape, a state that appears stable but is not the absolute lowest energy state. If a region of space were trapped in such a false vacuum for eons and something triggered its decay, the entire field could suddenly drop to its true minimum. The energy released in that transition would be incomprehensible, not exploding outward in matter, but flooding space itself with raw potential. This energy surge could effectively pump up the quantum foam, giving virtual particles enough borrowed energy to persist longer and grow larger, making the frothy chaos of the microscopic world manifest across light years. Another, even more exotic possibility involves the intersection of cosmic strings or the collision of domain walls, defects in space-time from the early universe. As these structures interact and unwind, they could release pent-up energy directly into the quantum fields, again causing the vacuum to erupt. The effects on anything passing through such a region would be bizarre and likely fatal. The constant macroscopic appearance and disappearance of matter would play havoc with the structure of atoms. A starship's hull might find sections of itself momentarily turned into a shower of pions or a burst of gamma rays as local space decided its constituent particles should not exist for a moment. Navigation would be impossible as the very geometry of space is fluctuating. Light passing through would be scattered and randomized, turning any view into a blinding, psychedelic static. This manifestation is more than a cosmic light show. It is a direct window into the machinery of reality. In our laboratories, we infer the existence of quantum foam and virtual particles through subtle, indirect effects like the Casimir force or Lamb shift. Here in NGC 262, the curtain has been ripped away. We are seeing, in a raw and unfiltered way, the universe's foundational uncertainty, the endless dance of something from nothing that underpins all of existence. It forces a profound philosophical shift. We often think of empty space as nothing. The quantum foam manifestation screams that space is not nothing. It is a seething, energetic plenum, a creative ferment where everything that ever could exist momentarily does. This region is the universe with its guard down, revealing that the calm, ordered cosmos we see is merely the quiet average of an infinite, chaotic, and endlessly creative storm. Amidst the quantum chaos, a different kind of living complexity drifts through the galactic arms. The symbiotic nebula is not a cloud of inert gas, it behaves. Over decades of observation, this glowing mass of hydrogen and complex hydrocarbons has been captured in a stunning time lapse, a slow-motion dance that eerily mirrors the basic rhythms of life. Dense, cooler globules drift through hotter, thinner regions. When they make contact, the smaller globule does not simply merge. It is gradually absorbed, its structure dissolving and its material seeming to be incorporated into the larger one, which subsequently brightens and expands. Elsewhere, a particularly large and energetic knot of gas will shudder and then cleave in two, with the daughter clouds drifting apart to begin their own independent cycles. When radiation from a distant star flares or a shockwave passes through, the entire nebula pulses in response, its internal motions quickening as if startled or stimulated. The visual evidence is undeniable and deeply strange. It looks like a cosmic ecosystem with gas clouds acting as predators, prey, and self-replicating entities. This immediately ignites the debate between the chemical and the biological. The natural chemical explanation is one of fluid dynamics and photochemistry. These are not living things, but complex structures behaving according to physics. The absorption events could be simple gravitational accretion, where a denser region pulls in surrounding material. The splitting could be the result of internal radiation pressure overcoming the cloud's own gravity, a natural fragmentation. The reactions to stimuli could be straightforward heating and ionization. Shine a light on any gas cloud and it will glow brighter. In this view, the nebula is a magnificent example of how simple physical rules can create the illusion of purpose and behavior, a cosmic mimicry born from light and gravity. But the patterns have a persistence that gives some researchers pause. The cycles of consumption and division appear to follow a rough rhythm, and the nebula seems to maintain a kind of internal equilibrium, with the total luminous output remaining stable even as individual components change. This nudges thought toward the fringes of science, to the idea of cosmic biology or panspermia taken to an extreme. Could this nebula be a nursery not for stars, but for a form of life utterly alien to our understanding? A life not based on cells and DNA, but on self-sustaining patterns in magnetized plasma and complex molecules, a metabolism powered by starlight, and a reproductive cycle measured in millennia. It would be a biology where the organism and its environment are one and the same, a living atmospheric thought. A more measured yet still profound hypothesis bridges these ideas. Perhaps we are seeing the precursors to biology, a demonstration of chemical evolution on a galactic scale. The complex organic molecules detected within the nebula, the amino acids and sugars, are not just ingredients. They might be participants in autocatalytic cycles, sets of reactions where the products help create more of the reactants, establishing a self-sustaining, growing chemical system. In this scenario, the nebula is not alive, but it is practicing. It is running through the steps that, on a warmer, smaller, rocky world, could eventually lead to the first protocells. The symbiotic nebula would then be a vast, slow-motion laboratory, showing us how the universe naturally experiments with complexity, building towards the threshold of life long before a planet is even formed. It asks us if life is a rare accident or an inevitable pattern the universe strives to create wherever the conditions, even in the cold dark between stars, allow the experiment to run. The universe's most violent events write their stories not in light but in the very fabric of space-time. In NGC 262, astronomers listened as that fabric tore. The signal was unmistakable, a rising chirp that culminated in a thunderous crash. Gravitational waves, ripples in reality itself, told the story of two supermassive black holes, each billions of times the mass of our Sun, completing their final, fatal spiral and merging into one. It was a discovery of monumental importance, a direct witness to the dance of cosmic titans, but the story did not end with that single, cataclysmic thud. In the quiet that followed, the detectors kept listening, and they heard it again. An identical chirp, the same exact fingerprint of that same merger, arriving from a completely different direction in the sky. Then another echo and another. These were not random noise or unrelated events. The data streams lined up with chilling precision. It was as if someone had recorded the sound of a cannon firing in a valley and then played back the exact same sound from speakers hidden in the hills all around you. This is the gravity wave echo, and it suggests space-time is not the simple, three-dimensional stage we perceive. According to our standard models, gravitational waves travel in straight lines from their source like ripples on a pond. They do not bend or reflect under normal circumstances. For an echo to arrive from a different direction, something must have bounced it. But what in the universe is large enough and smooth enough to reflect a gravitational wave? The leading theory reaches into the realm of string theory and suggests we are hearing reflections from a higher dimensional boundary. Imagine our universe is a three-dimensional membrane or brain floating within a higher dimensional space. The colossal energy of the black hole merger might have sent gravitational waves not just across our brain, but through the bulk of that higher dimension. When those waves struck another distant brain, or perhaps a fold in the geometry of our own, they could have reflected back to us, arriving from an angle that seems impossible from our limited perspective. A three-dimensional diagram of this would show the initial wavefront expanding from the merger like a sphere. But then, secondary, identical spheres would appear to emanate from points in empty space, as if the original wave had passed through invisible mirrors hanging in the cosmos. Another, equally mind-bending possibility involves a natural network of wormholes. If the fabric of space-time in this region is riddled with shortcuts connecting distant points, the gravitational waves could have taken multiple routes to reach us. One signal comes the direct way, another takes a detour through a wormhole, emerging from a different point in the sky but carrying the same information. This would mean the echo is not a reflection at all, but the same message delivered through a cosmic backdoor. Both ideas challenge our fundamental understanding of how gravity and space interact. They imply that the universe has a hidden architecture, extra dimensions or tunnels, that gravity can access but light cannot. This makes gravitational waves more than just messengers of cosmic events. They become probes of the universe's deepest geometry, a sonar pinging off structures we could never hope to see. Each echo is a map of a hidden wall, a measurement of a distance through a dimension we cannot perceive. The silence after the initial crash was not empty. It was full of whispers, each one repeating the same story of an ending, but telling a completely new story about the shape of everything. The echoes of a black hole merger may have bounced off unseen walls, but in a quieter corner of the galaxy, the walls themselves appear to be dissolving. A single, unassuming point in the void emits a steady stream of radiation that should not exist. The particles and energy signatures streaming from this source match nothing in our standard model of physics. They are not protons, electrons, or gamma rays. They are something else entirely exotic, high-energy entities that decay almost instantly into a shower of familiar particles the moment they manifest in our space. Scientists have named this phenomenon the dimensional bleed-through, and it is the closest we may ever come to touching a higher dimension. To understand what we are seeing, we need to step back and consider the shape of reality itself. In our everyday experience, we live in three spatial dimensions: length, width, and height. Time is often considered a fourth, but many theories that seek to unify all the forces of nature, particularly string theory, require more. They propose that the universe actually has 10 or 11 dimensions. The extra dimensions are not vast, empty expanses like the ones we know. They are thought to be compactified, curled up on themselves at scales a billion times smaller than an atom. They are everywhere but hidden like the thinness of a piece of paper. Our entire cosmos, with all its galaxies and stars, might exist on a three-dimensional membrane or brain, floating within this higher dimensional space, often called the bulk. The particles we know and love are like vibrations confined to the surface of that membrane. They cannot leave it, but what if there was a flaw, a tiny tear, or a weak spot in the fabric of our brain? The dimensional bleed-through suggests exactly that. At this location, the compactified dimensions may be momentarily unfurling, or our brain may be pinched so thin that particles from the bulk can leak through. These are not particles from another universe in the science fiction sense. They are particles that naturally belong to the full, higher dimensional geometry of reality. When they spill into our confined three-dimensional space, they are like a three-dimensional object being forced through a two-dimensional sheet of paper. The paper cannot contain the full object, so it appears as a series of bizarre, fragmented cross-sections. In our case, these higher dimensional particles manifest as bizarre radiation that immediately shatters into things we can recognize, leaving a unique fingerprint of their impossible origin. Observing this is like standing outside a house and hearing music through the walls. You cannot see the instruments or the players, but the sound bleeds through, telling you something complex is happening inside. Here, the music is a cascade of unknown particles, and the wall is the very boundary of our dimensional reality. The abstract visual scientists used to represent this are mind-bending. Picture our three-dimensional space as a flat, grid-like plane. Now, imagine a brilliant, complex knot of light, a higher dimensional object slowly passing through that plane. From our perspective trapped on the plane, we would not see the knot all at once. We would see a point that suddenly glows, then erupts into a spreading, shifting pattern of strange shapes and energies as different slices of the object intersect our world, before it fades as the object passes completely through. That is the hypothesized visual signature of the bleed-through. The implications are staggering. If this interpretation is correct, then this point in NGC 262 is not just an astronomical object. It is a puncture wound in reality, a place where we can directly sample the physics of the bulk. By studying the decay products of these exotic particles, physicists could, in principle, deduce the geometry and properties of the compactified dimensions. Are they curled into circles or more complex Calabi-Yau shapes? Do forces behave differently there? This one anomaly could provide experimental data for theories that have until now been purely mathematical elegance. It transforms a distant point of light into a keyhole, and we are desperately trying to glimpse the vast, hidden architecture on the other side. But if space itself can leak and echo, what if the entire galaxy is more than just a collection of strange parts? Our final and most speculative phenomenon asks if NGC 262 could be a single, coherent entity. When researchers mapped the faint background of quantum fluctuations across the entire galaxy, they found something that defied simple randomness. These tiny, probabilistic events, the very static of empty space, were not entirely independent. Over vast distances, they displayed subtle, large-scale correlations. It was as if the galaxy's quantum background noise had a faint, synchronized rhythm. Visualizing this is a challenge, but imagine an overlay on an image of the glowing spiral. Superimposed on the stars and dust are faint, shimmering lines of connection, a web of correlations linking one region to another in a pattern that eerily resembles a neural network, a cosmic-scale brain with filaments of influence instead of synapses. This is the foundation of the conscious cosmos hypothesis, the idea that the galaxy itself, or the field within it, exhibits a form of proto-consciousness. The scientific skepticism here is immediate and necessary. Correlation does not equal causation, and certainly not cognition. the observed patterns could be the result of unknown physical forces, residual effects from the galaxy's violent formation, or even an artifact of our own measurement techniques. The vast majority of physicists see this as an intriguing statistical anomaly to be explained by new physics, not new philosophy. They search for a unified field interaction or a long-range quantum force that could orchestrate such subtle synchrony. The hypothesis pushes far beyond the current boundaries of empirical science, yet the philosophical implications are profound and haunting. If a system as complex as a galaxy, with its swirling masses, energy flows, and intricate feedback loops, can develop large-scale correlated patterns, does that constitute a very slow, very alien form of thought? This is not about stars thinking in words. It is about a system processing information on a scale we can barely perceive. A neural network, whether biological or artificial, functions by the weighted connections between simple nodes. Could the gravitational interactions between stars, the magnetic fields threading nebulae, and the quantum vacuum fluctuations between them act as a natural, unimaginably vast computer? Its thoughts would be the gradual, majestic evolution of its own structure, the birth of star clusters, the migration of spiral arms, the silent decision of which star lives and which dies. The output of this computation would be the galaxy itself, continuously rewriting its own form over eons. This idea forces us to confront the nature of consciousness itself. We define it by our own human-scale experience, but what if consciousness is not a binary state but a spectrum? What if it is a property that can emerge in any sufficiently complex, interconnected, and self-regulating system? A galaxy is certainly complex and interconnected. The conscious cosmos hypothesis suggests that NGC 262 might not just contain mysteries, it might, in some ineffable way, be contemplating them. It is the ultimate strange phenomenon, one that asks if the greatest discovery we could make in this distant spiral is not just that the universe is weird, but that it is, in some ancient and silent way, awake. We have wandered through a gallery of cosmic impossibilities, from a phantom pulsar that broadcasts from nothing to a nebula where light itself stands still. Each of these 25 phenomena is a crack in the facade of our understanding, a place where the universe seems to wink at us, knowing its secrets are still safe. This journey through NGC 262 has not just been a catalogue of weirdness. It has been a confrontation with the limits of physics, imagination, and perhaps even reality itself. We have seen hints of engineering on a scale that treats stars as building blocks and whispers of natural laws that operate in dimensions we cannot perceive. We have witnessed time fracture, information defy destruction, and the quantum world erupt into plain view. So where does this leave us? The ultimate question hanging over this entire strange galaxy is one of origin. Are we looking at a cosmic zoo of freak accidents, a collection of natural wonders so rare and extreme they exist only here, pushing the laws of physics to their breaking point simply because they can? Or does the sheer concentration of such profound anomalies point to something more deliberate? Could the fingerprints of intelligence be etched into the very motions of stars and the structure of space? Science, in its beautiful rigor, demands we first exhaust every natural explanation. Yet, the human mind cannot help but wonder if we are seeing the first, faint traces of a story much larger than our own. The universe is under no obligation to make sense to us, but in NGC 262, it seems to be trying to tell us something extraordinary in a language we are only beginning to decipher. Which of these 25 mysteries captured your imagination the most? Was it the singing black hole, the silent supernova, or the idea of a galaxy that might be awake? Let us know in the comments below. If you are fascinated by the edges of reality, be sure to subscribe for more journeys into the cosmos's deepest puzzles. Until then, keep looking up. The universe is far stranger and far more wonderful than we ever dreamed.